Look, everyone's putting solar on their RVs and everything, but what about a wind turbine? Have you ever thought about that before? My name is Adam Foltz, and I'm the sole owner and operator of SolarArkElectrical. I design, install, diagnose, and even repair solar electrical systems for pretty much any vehicle, anything from RVs, vans, trucks, anything in between. I'm a degreed power systems engineer, and I've always had this fascination with renewable energies. Whether it was solar, wind, or even hydropower, I always wanted to get a homestead or something like that, just to, experiment with all the different ways of generating electricity from the natural resources around us. When I started living as a nomad, I was doing solar installations for people down in Quartzsite, Arizona, and I started to notice a recurring theme. People always had too much solar for what their actual energy needs were. And that's not necessarily a problem, but it cost them a lot of money, and it got me thinking, are there other ways to compensate for solar when the sun's just not out shining as bright as we want it to be? Coincidentally, one of the things you always saw on Quartzsite was flagpoles mounted like 15, 20, 25 feet up high with these big flags or sometimes even antennas mounted on top of them. But you never really saw anyone with wind turbines. I mean, when I was there, I saw maybe one or two, but they weren't mounted very well, and it got me wondering, what if somebody could create a better solution that actually generated reliable power when the sun wasn't out? Next thing you know, I was spending $600 on a wind turbine and another $400 on all the mounting equipment, and suddenly I had a wind turbine mounted on my trailer for myself, and the results were quite astounding. While I wasn't generating over 100 watts of power consistently with this wind turbine, I was getting a significant amount of energy.
This is getting nuts really quickly. That thing is cranking.
I was typically seeing anywhere from 25 to 80 watts of power generated from my wind turbine, typically averaging about 50 watts in 10 to 15 mile an hour winds. Now, while that might not sound like a lot compared to something like a 100-watt solar panel, you have to consider the amount of time that this thing is running for, because energy is power over time. So while a 100-watt solar panel might reliably generate about 80 watts during the day, it's only doing that for a limited amount of time. Typically, we calculate this in peak sun hours, and it's about 4.5 peak sun hours, sometimes 3.5, depending on what part of the country you're in. But you would take 80 watts times 4.5, and what does that give you? That would be 360 watt hours of energy generated by a 100-watt solar panel mounted permanently flat on top of an RV roof. Compare that to a wind turbine now. I'm generating 50 watts on average, but let's say it's windy for 12 hours throughout the entire night. How much energy is that? We're talking about 600 watt hours of energy being produced by a wind turbine overnight when the solar panels aren't even working. Now consider how much energy your solar panels aren't producing when it's cloudy or stormy out, and supplement that with a wind turbine, and suddenly you would go from 90% electrical independence to 100% electrical independence, plus some extra actually. So let's talk about some of the misconceptions I often hear with these micro wind turbines. I'm always hearing people complain that wind turbines don't generate much power, but as we just talked about, it's more about energy than it is power. Let's look at some of the recordings of the raw data that my power meter shows my wind turbine generating in these heavy winds. At low wind speeds at about 6.5 miles an hour, this is all I see, less than an amp. Raise the wind speeds up to about 8 miles an hour, and you start to get results more like this. The wind turbine might look like it's spinning really fast, but that's because of the physics involved. Turbines don't spin much faster whether they're spinning at 6.5 mile an hour winds or 30 mile an hour winds. It's all about the power being produced, and you can only see that with the power meter. Keep in mind these power numbers that we're seeing between 0 and 2 amps are being generated in winds that are less than 10 miles an hour. You might start to be able to feel the wind somewhere between 6.5 and 10 miles an hour, but it's not going to be uncomfortable. That doesn't happen until around 15 miles an hour. The wind was pretty chaotic in this clip. It was coming in bursts instead of just all at once. You could watch how the power actually dropped down for a little bit before spiking way back up, and that's when I started to walk around, and you could just kind of see what happens from there. This was in Moab, Utah, and it was probably one of my favorite places that I've set up the turbine. Despite having my wind turbine set up in 20 to 30 mile an hour winds several times now, the most power I've actually squeezed out of it is 150 watts. This actually has nothing to do with the turbine's limitations in efficiency, and it has everything to do with how I mounted the turbine. I mounted my turbine on a telescopic flagpole because I need to be able to take it up and down and put wires through the pole from the top all the way to the bottom before feeding it into my electrical system. The downside to a telescopic flagpole without pins is that it has a tendency to slip when there's too much mechanical force on it. And when you're talking about 20 mile an hour winds pushing on a 20-pound turbine on top of this 10-15 foot flagpole, you're going to get so much stress on that flagpole that it actually starts to collapse the flagpole itself. And when the flagpole starts to slip down a little bit, then the steel cables get loose, and then this turbine starts wobbling around, and you don't get as much power out of it. And this is just a mechanical issue that I've been working through since I started this project. Here's a little bit of a video update. It's about midnight right now, and we are getting consistently 5 amps because the wind is just absolutely ridiculous right now. We have managed to push our peak wattage up to almost 150 watts, and when that is happening, it is scary as hell. Like, it feels like the entire trailer is going to tip over when it gets to that strong wind speeds, that we're getting that much power. I also often hear people complain about the noise that these turbines produce, but really it's not that bad. I mean, check these clips out for yourself and tell me what you think. In this clip, you can hear the nose cone rattling as the turbine spins, but this was an easy fix with some alien tape. There it is, much better. Literally just 3 strips of alien tape, and the sound was completely gone. Now check this clip out in the dead of night. Compared to an AC unit or even the wind itself, you can barely hear this thing cranking. And check that out, I hit 125 watts during this session. Here's a clip of me measuring the wind speeds that night. It was absolutely crazy. Anywhere from 10 miles an hour to over 25 miles an hour, and I was generating 125 watts from that. Keep in mind, the only thing between me and this turbine when it's cranking like that is a 3/4 inch sheet of plywood and a little bit of aluminum. That's it. Alright, well, I could talk about these wind turbines forever, but I have to end this video eventually, and this is really only meant to be an introduction to my project. If you want to see more content related to this turbine, or even just to my trailer, my way of life, my electrical work, let me know in the comments, and be sure to like and subscribe for future videos. And if you find yourself out in the Pacific Northwest or the Rockies, and you need some electrical work done on your rig, give me a call. My phone number is 623-276-2413, and my website is SolarArkElectrical.com. Thanks for tuning in, and I'll see you next time.